Hello, Jacob. Can you hear us?
I can hear
Yeah.
very clearly.
Yeah. Okay. Yeah, we are live. We are checking out if the LinkedIn link is working. It looks like it's okay now. Hopefully, people, the audience, can log in. We have alternative link. We're streaming also on YouTube, and that's on the Offshoretronic SL web page or YouTube channel, and also on Facebook. So hopefully people can join us today. We have a quite interesting subject. Unfortunately, Stefan from PES Wind is not available to attend and to do the introduction. So that's why we are starting with our own introduction. He has an emergency, he had to go to hospital with his daughter. Hopefully everything is okay over there. And yeah, I would like to start with Jacob. If you could give a quick introduction of yourself and GBO, and start with your presentation on this webinar. We have an outlook on the 10-year monopile installation, but also the fabrication and the demand. And for the last two, Jacob can show you everything.
All right. Thank you very much for handing over, Jeroen. Welcome to the audience. My name is Jakub Seehafer. I'm technical and commercial advisor at JBO. I'm 14 years in offshore wind, and JBO is a design and engineering consultancy for offshore wind foundations, substructures, topsides, and other technical challenging solutions. I'm now going to introduce to you my market study I'm doing since a couple of years, and it's about the trends for monopile foundations until 2033 at 10 years outlook. Let me share my screen. And run the presentation. If you want to get more information about JBO, our services that we provide, feel free to scan this QR code on this first slide, or simply look up JBO at LinkedIn. We are very happy to see you there. When it comes to the trends for monopile foundations, I'm going to cover the following topics. It's going to be the trends dimensionally wise, so technically wise. It's going to be the monopile fabrication demands. And last but not least, the monopile fabrication capacities that we see in the market at JBO. So starting with the dimensions. We need to differentiate between the average monopile weights that we expect to reach until 2033 and the maximum dimensions for those monopiles. Here on this slide, I've prepared an overview that reflects and is covering the monopile weights that are also related to the wind turbine generations that we expect to reach until 2033. In this case, the average weight that we expect to observe and to see for monopile foundations for the 14 and 15 megawatt class of wind turbines is 1,700 tons. From roughly more or less 2027 on, we expect to observe wind turbine generations 15 up to 18 megawatt and a monopile average weight of 1,900 tons. For the 18 until or up to 20 and 20 plus wind turbine generations, which we expect to observe from the 2030s on, we expect an average monopile weight of about 2,100 tons. These weights that we see on the slides are important to us for the further slides and for the evaluation of the market capacity, which I will come to in a few minutes. When talking about the maximum monopile dimensions and figures, we actually should concentrate on 3 of them. It's the maximum outer diameter, it's the pile length, and the pile length that we expect to reach until 2033. And these are the values that we at JBO see. It's the maximum outer diameter of 12.5 meters. It's the maximum weight of up to 3,000 tons and the maximum length of 100 centimeters that we expect to observe and to reach by 2033. So far for the dimensions. Let's now come to the demand. And this is something I would like to introduce to you by inviting you on a journey from 2024 up to 2033. I am highlighting here in a diagram the fabrication demands specifically for each year and specifically and mentioning markets that are highlighted in the background. The darker the market becomes, the higher the amount of those specific demands, in this case for 2024, which is roughly or more or less 500 units. The core markets, these fabrication demands need to be prepared or need to be, the monopiles need to be fabricated, are Central Europe, mostly UK, and the US market. 2025, we expect to reach a higher demand for fabrication of monopile foundations, reaching a value of around 700 units. Still, you can observe and see in the background that the Central European market, the countries' markets around the North Sea, but also Baltic Sea, have the highest demand for fabrication of those 700 units, followed by the US, South Korea, and Taiwan. You also see on this slide already that the columns that are highlighting or reflecting the fabrication demands have different colors. These colors, they reflect the confidence for the projects that are standing behind those columns. In this case, more than half of those 700 units have a high confidence, while less than half of those 700 units have a medium confidence. And this is something we will also observe when going to 2026. The fabrication demand is rising dramatically, reaching a value of more than 1,000 units. Already here, we can see that the core markets remain the same, obviously. It's Europe, Central Europe, the states and the markets around the North Sea and Baltic Sea, but also the US and Far East, Japan, South Korea, and Taiwan. I need to mention that this diagram and these slides, they cover the global demand for fabrication of monopile foundations, except for the Chinese market. As we at JBO see this Chinese market as an own domestic market, which has its own demand and its own fabrication capacities, which of course I will come to in a few minutes. 2027, the fabrication demand becomes even higher, reaching maximum fabrication demands of more than 1,200 units. From now on, so from 2027 on, we expect to also observe projects where the foundation types are not yet defined. The database I am analyzing here and I'm studying here is the 4C offshore database, which is then mentioning those projects as bottom fixed foundations where the exact type is not yet defined. Analyzing those projects, me, myself, and my colleagues at JBO, and checking the water depth for those projects, we come to the conclusion that at least for the water depth, these projects where the foundation type is not yet set or defined, they qualify, most of them qualify to become monopile foundation types. 2028, we expect to reach an even higher value, of more than 1,400 units. Some new markets already appeared. You saw on the slide before, it was Brazil, but also Scandinavian countries like the Norwegian one and Finland. 2029, the value becomes even higher, reaching a value of almost 1,600 units. And from now on, we can also see that the far we get to the right, so the more we get to the future, the market becomes more uncertain. This is obvious. This is obviously the reason the higher the distance from today on, the higher the lower the confidence that the project will become a real project at the end. From 2030 on and the 30s, the values for the fabrication demand seem to go down. There's a certain reason for that. I could ask you, the audience, right now, but I want to save time and give you some, let's say, outlook on that. The projects that are mentioned in the database in 4C Offshore in this case are the projects that are currently under development or are currently developed. We expect that from 2030 on, although these values seem to go down for the fabrication demand, that there will be more projects that will be simply put into the database within the next few months and years, and the values and the projects will pop up, influencing the fabrication demand. These question marks, they shall reflect and they shall show that we at JBO, we expect that the fabrication demand will at least remain at a certain very high level or even go higher. This slide reflects the share of the markets for the fabrication demand. You can clearly see that the European market is by far the biggest market when it comes to a comparison between those fabrication demands, covering more than 50% of the total demand, followed by the Far East markets, Japan, Taiwan, and the North American market, obviously the US market, and then the rest. When studying this fabrication demand, we also need to check for the capacity. Therefore, I have prepared a slide to introduce to you some of the existing monopile fabricators in Europe and in the US. Many of you or some of you will probably know all of them. There are currently also fabrication yards are under construction, or investors and shareholders have released press releases and news that soon they're going to set up new facilities in Europe as well. I hope I did not forget any one of them. If you're missing one, feel free to reach out to me. This slide reflects the fabrication capacity in Europe and in the US. Again, it covers the capacity, the fabrication capacity of the existing fabricators in Europe, in the US, but also the ones that are currently under construction or will soon or could theoretically also offer their fabrication capacities soon. You can clearly see as well that the fabrication capacity curve is going up. Something that we at JBO have considered here is the average weight for the output of those foundations. As the fabricators, they usually give out their fabrication capacity in steel ton per year. And as we are here dealing with the output rate of monopiles per year, we have specifically for each and every year considered the average monopile weight that we expect to reach. So if we would have not done that, the capacity curve would be even higher, which we do not see as realistic when considering this average weight of monopile foundations. In other words, the heavier the monopile average weight becomes, the less the output rate at the fabricator. And this has been considered here in the study already. Now, you're curious about the capacity versus demand curve. This is something I was also was excited about to see, and this is the result. We can clearly see that in 2026, 27, 28, and 29, there is seems to be a higher fabrication demand for monopile foundations than the fabrication capacity. Let's call it a bottleneck, obviously. There are some mitigation factors that could help to mitigate this bottleneck, which is obvious. Long-term, new additional monopile facilities. Mid-term, upgrade of existing ones that so far have not been mentioned or published in newspapers. But since we also got short-term need for mitigation, I was wondering doing this study whether I did a mistake actually, and came to the conclusion, well, actually, there are more capacities for fabrication worldwide, and it's Far East, means Asia and China. And since this slide does not cover these capacities, I've prepared some more slides for you. This slide considers not only Chinese fabricators of monopile foundations, but also fabricators around China, means in Far East and Near East. That does not mean that they are currently fabricating monopiles, but they could offer soon to do so. They have capabilities. Some of them can offer and do offer transition pieces, for instance. So that means that they have these growing lines already prepared to offer these kind of products, big, huge tubes to the market. Now, when you talk about the fabrication demand, especially in China, and the fabrication capacity in China and the Far East market, we can clearly see that the capacity for fabrication of monopiles is higher than the demand. I've highlighted the gap here in red. And this, from my perspective, from our perspective at JBO, is the export capacity of China right now. Now you're curious how this diagram would then look like this one, covering the European and the US American capacity, and adding the export capacity, the potential export capacity of China and the Far East fabricators. Now, this is how this diagram would then look like. Since the gaps are different specifically for each year, this diagram looks that, let's say, different. Now, if we put this maximum trend line onto our demands for fabrication worldwide, except for China, considering the export capacity of China, we can clearly identify that we have mitigated the bottleneck that we have identified before when not considering the fabrication capacity in Far East. Even if we consider a higher demand for fabrication from 2030 on. This is that kind of conclusion that we can set on this slide. My recommendation to the market is important, actually. What I really recommend is to be on time. All these values, all these characteristics of this diagram, it covers and considers the current and past press releases of the fabricators. So if there is one in the audience, please be on time. Please make sure that your capacity will be available to the market, because the market obviously needs you. This is something we are offering currently at JBO to you for free today. And if you have more needs for that kind of support, feel free to reach out to us. As we do not offer the engineering and design services for offshore wind foundations only, we also do market studies, we do supplier advisory, and can support you in your tender phase and your pre-qualification phase of foundations. This is the last slide. Feel free again to reach out to us. I'm happy to answer your questions if there are any, and will now stop sharing my screen and giving back to Jeroen.
Yeah, you can open your screen again one moment, because I think it's important for everybody that would like to reach you and also come with questions and follow up on your presentation, that they have the correct email address.
I see.
So maybe you can just open it one more time.
Sure.
Yeah. Thank you, Jacob. It's an excellent presentation. I will just open the screen again. Yeah, there it is. For people that would like to know a little bit more about GPO, they can assist in a lot of areas to the offshore wind industry, but also other projects. I just have a few remarks that there is a lot of people that try to attend on LinkedIn. It looks like that LinkedIn has some problems. I don't know. There are quite a lot of people looking at LinkedIn as well, but I would only say to the people that attend this, we also streaming on YouTube on the Offshoretronic SL tube, that's like channel, and also you can view the total webinar again afterwards. We will leave a copy on YouTube there. So if the presentation went a little bit too quick and you want to go back again and read it again, you have this option over there. Let me start with the second presentation that we were planning to do, because Jacob has given us an excellent overview of the fabrication capacity and the demand, worldwide demand for the offshore wind. And what's missing a little bit in this presentation, and that's why I like to step in and complement this presentation of the webinar, actually with an extra presentation on the TNI. That's a transport and installation market, and that's we are focused only on the monopile installations today. There are also other types of foundations like jackets or floating, but we are specifically focusing on the monopile, as monopiles are more or less 80% of the total market. So I will start my presentation. Jacob, you want to add something else before we start?
No, I think I'm fine.
Yeah. We see also people sending comments. Thank you for that. And also afterwards, we try to do a Q&A session, both of us. If people has any questions, then we can answer that during the webinar. However, because we are transmitting on different channels right now, it could be a little bit difficult, but try to send your comments. And always you can, afterwards, you can drop us an email. That is also a way that we can follow up on this. Okay, we have seen from the presentation of Jacob that we have a good overview of the demand side, and that is mainly driven. Everybody that's working in this industry or has some relation with offshore and marine understand that offshore wind is an area to be in, and it's also driven by the government policies. We have an energy transition, and also some countries like to develop jobs in this sector. Also, the energy security and independence is a hot topic, and it's also giving extra demand, and the environmental benefits. And what we have tried to set up is a sort of triangle. Some people maybe see some similarities with the fire triangle. You need three components there: the heat, fuel, and oxygen, to have the fire burning, or you want to kill it. But in this case, we want to keep the offshore wind installation market. We want to keep it in motion. So all these three elements need to be basically green. The supply chain, that's also part of the report of Jacob from GPO. That's the monopile fabrication capabilities and capacity, and also the steel deliveries and onshore transportation and lifting. And we see that there's sufficient supply on that side. And also the monopile is proven technology, and it's also the quality of the monopiles these days are really secure, and there is also some improvement in the design. Today we go and have a look on the right side, bottom end. That's the transport and installation capacity, and to see how we are at that area. And you will be probably a little bit surprised, and hopefully people not getting shocked. Before we start to dive in all the numbers, we want to highlight a little bit that we have tried to come up with a really high transparent outlook. And to come with this outlook and transparent outlook, we used a lot of data that is available privately and publicly, and we have tried to verify this as well. So it's in the bottom line, we put here as well, if it's prediction or assumption, we will highlight it. What's important to highlight now is well that we are looking at only the European and the US and Asian market, and excluding China, because the vessels from China, we don't believe they will entering other markets. But for now, we have excluded China in this report. Also, the outlook report on the monopile installation vessels reflects only monopile installation units with capacity above 1,500 ton. There's a lot of vessels, mainly jack-up vessels, that have around 1,600 ton crane, and we didn't take them into account in this report, as we see the monopiles are getting already bigger, and some other vessels as well, they are not compatible. We have used also confirmed engineering data and also the track records of the vessels. We just have tried to highlight it a little bit, because maybe some of the audience are working for a certain company and say, oh, this is not correct, but we have tried to do our best. There is also something in the industry that is still a little bit a different way to look at the size definition for the monopiles. And in this report, I try to just highlight it. We have 4 different sizes of monopiles. And if we are talking in this report about the XL, then we talking about the monopiles between 1,500 and 2,000 metric ton. The dual XL is the 2,000 up to 3,000, and the triple XL is 3,000 to 4,000. There are maybe some other companies and other institutions or research and that are using a different way, but this is for this report, these are the numbers we are looking at. There is also a quadruple XL, monopiles between 4,000 and 5,000 metric ton, but we don't believe that that will come very soon, and also that is a very niche market. We will later on in this slides, we will show you a little bit why. Again, we using the data from GPO, and that is the monopiles in size and also the maximum size. And this is an average, and there are some exceptional cases, and they are excluded. What type of vessels are used? Right now we see 4 types of vessels assigned to offshore. installation, that is the monohull vessels. Right now, 4 units are in operation, and we see that as the most efficient T&I solution on market. There are some more vessels that are from the oil and gas, but we don't see them really compatible for the larger monopiles, and they're also not operating as such right now. Jackup, that are jackup vessels, they are filling in a little bit a gap that is left over by the monohull units. So some operators with these large jackup vessels has equipped with mission equipment to install monopiles. Right now there is that's a semi unit that is a semi-submersible vessel that's also converted for the installation of monopiles. The vessels are extremely costly to operate and to run, high fuel consumption, but as there is a shortage of vessels, this operator has stepped in and is offering also their vessel for installation for monopiles. Another vessel that's a little bit of one of a kind, that's the U-barge. The name of the vessel is Zwanen from Van Oort, from the Netherlands. And that's a vessel that can operate in shallow and sheltered waters. And we took it because the vessel is getting a large upgrade right now, so we took it in the report as well. If we look at the overview of the vessels that are operating, and maybe we missed one vessel, let us know. But we believe we have a good overview. We know one monohull vessel operating in Taiwan is not on the list, but that's because the vessel cannot operate with monopiles bigger than this 1500 ton and safely. So that's why it's not shown on this graph. Right now we see 4 monohull vessels operating. 2 of the vessels are in the US and 2 in Europe. And shortly also one of the jackups is going to operate in Taiwan, and that's the Blue Wind. Again, there are some other jackup vessels operating with smaller monopiles below the 1500, but we didn't take them into account because they will be phased out very quickly. There are also the coming years some new building vessels, mainly jackups, coming on market, and it's very difficult to point exactly when they're coming on market because there is always a risk of delivery delay with the shipyards, transit time from China, installation of the mission equipment can take some additional delay, but we have listed them down here. If we go to the right, in 2027, we have one vessel, a monohull vessel, and that is a project that is under the umbrella of Geotronic. We are the project developers for that vessel, but it's still to be addressed if this vessel will come. But it is prepared, and it could be an option to get that vessel online in 2027. It's a conversion. It's not a new build vessel, so there is a shorter lead time on the vessel. Hopefully we can get that online in 2027. There's also an option of an additional jackup vessel showed here. It's not clear if this will be executed, the option, but we put it on the list as well. And then there are new building slots in China, mainly in China, but the price tags are extremely high, and so far we haven't seen any confirmations that somebody is ordering a new vessel. So the next slide is giving a little bit an overview of all the vessels, and we have given the vessels also a competitive score. And how do we get this score is mainly based on efficiency, the capacity, the emissions, the day rates, and the safety risk of these vessels. And if you score 100%, you have one of the best vessels on the market, basically the best vessel that we see. Some vessels are a little bit lower in score, and that has to do with the day rate or the emissions, and also on the capabilities of the vessel and the amount of monopiles they can transport. We have on the right side of this slide, we have a number, and that's the optimum monopile per year number that this vessel can produce or install in this case. that is a number that we see if the vessel is doing a normal season with not too many operational issues and downtime and maintenance periods, but also a vessel, if it's need to be mobilized from Europe to the US or vice versa, it's going off the, but an optimum number, and this number can maybe a 10% high or low, but this is a number that we feel that should be an optimum number for that vessel that can install the amount of monopiles. This is a competitive score for monopiles between 1500 and 2000. So we have another one. So we go in steps. We go up. We go to the dual XL. We'll open that slide straight away. You can see some of the vessels, they went down in the score. And just to give you a few examples, the Orion was 100%. Now it's going to 70%, and that has to do because the mission equipment, that's the pile gripper and the upending tool, is only rated to 2,500. Some other vessels like the Boca Lift and the Strasnov, they can only carry 2 monopiles instead of 3 XL. If they go to the and they also have the limitation on the mission equipment. So they get the lower score, and also the number total output and monopiles that they can install during 1 year is going down here. You can see also we were in the first slide, we had 5 jackups. I can quickly go back. Here we have 5 jackups, but the 2 smaller jackups from the second generation or third generation jackups, they have only a maximum installation capacity of 2000. So in the next slide, as we go back again to the 2000, 3000, the dual XL monopiles, you can see that they are already obsolete to install these larger monopiles. We have also a little bit a new vessel on market. There is no track record. That's the T-Alf of company Herma from the Netherlands. That's the large semi-submersible vessel that will start to install monopiles this year. And we have no track record of that vessel yet, and it's depending on how their operations is going. The vessel will be operating on its own offshore, and there will be feeder barges with tugboats bringing the monopiles offshore. But we estimate more or less 100 monopiles in 1 season if everything goes well. If we go to the triple XL, it's getting really interesting because we can see that a lot of vessels are already out of the list. And that has to do with the, not with the crane. For some of the vessels, it's not the crane capacity, but it's more the mission equipment capacity that is saying that the vessel cannot grow higher. We come back later in another slide. We show a little bit more details about this. But we see really a low number now on the output yearly. So if we get evolution of the wind turbines really quickly, that we could have a serious issue within the industry. Let me go quick to the next one. That's the quadruple. We don't see any requirements in this area yet. There are some rumors in Taiwan that they are looking at monopiles over 4,000, but this is a very niche market. Plus, this is also probably very difficult to produce. We heard some rumors that in China maybe they can build these monopiles, but so far there is no really evidence or information that we can refer to. If we make up a summary of the last 4 slides, we can see a number. We get a number per year that those vessels can install, and this is also we divided in the XL monopiles, the dual XL, the triple XL, and quadruple. And you need to understand, and I hope everybody understands what we put down here on the slide, is that if some vessels are operating in one segment, they can of course not operate at the same time in the other segment. So I hope you can understand that a little bit. So now we come to the numbers. We get a lot of numbers here on this screen, and it's no need to go to look at this because we made a nice graph. But this is just an overview of in the top end you can see in green the optimum capacity of the monopile installation of the vessels in the different segments. Then we see also the numbers from GBO, the confident market demands, and the total of that. We have also taken the total fabrication of the report of GBO, and then we can draw some conclusions. And then we see in the blue, highlighted blue boxes underneath in the columns, the numbers in 2026, 2027, we get a shortage of vessels, and it's better maybe we jump to this chart that gives maybe a better overview. So to explain a little bit the lines, we have the top line, that is the fabrication capabilities from Europe, Asia, and US, plus the leftovers from China. And we have also the line that is the wind turbine generators, and that is multiplied by 10 kilowatt. So when the output of the turbines are going up, the size of the turbine requires also bigger foundations. So these are the lines that we have taken also from the report from GBO. And the yellow line is the line that are the vessels that are available. And then in the bottom we have put the numbers. So you can see clearly already from 2027 there is a shortage. It's also quite interesting to just to highlight a little bit that the red line is the red line that was given the bottleneck, and that's the fabrication between Europe, Asia, and US. And what we understand also from Jacob, we had some discussions there that the monopiles basically from China will be transported and will be used in Europe, and some of the monopiles that will be fabricated in Europe are going to the US area. So there's a lot of demand on the heavy lift transport vessels to cope with all this transport. And yeah, we will not draw any how can I say, draw any comments on that, but we see this some mismatch worldwide, and hopefully over the coming years there's a lot of vessels that have just started operation as well. We see the last 4 years that the monohull vessels coming, going to operate in DP, installing quite efficient monopiles now. So maybe there will be some adjustments coming, hopefully. The next one, we have also made the same way as the first chart we showed you, a possible worst case scenario. And that is, everybody is talking about that in the industry. What's going to happen if we get this 18 megawatt or the 20 or the 24 megawatt wind turbines? What's happening then? So we made some predictions here, and you can see in the green line that are the wind turbines. Right now we are installing wind turbines between 14 and 15 megawatt, but slowly we will go to the 18, 20, 22, 24. So we made some scenario and a prediction on the worst case, what can happen with the evolution of the wind turbine. That will affect also the monopile, and especially monopile weight in combination with deeper water. And that's the variables that we put in the top, the wind turbine size and the soil condition and what type of monopile you're going to use and the water depth, and maybe some additional environmental requirements. That will give you a design of a monopile that can go really quite up in weight. In this line, it's a brown line and it's a monopile weight. We made some red dots, and that are the red dots when some of the vessels are getting a little bit obsolete. And that has to do with the lifting capacity of the vessel, or the combination lifting capacity and mission equipment. So very quickly we can see already that 2 jackup vessels getting obsolete because the maximum safe operating capacity of that jackup is around 2,000 tons. A little bit more going up, we see already 3 mono hull vessels getting obsolete, basically on the mission equipment. And then we have also, when we going bigger in monopiles, we see more vessels getting obsolete. You can see the line at the end, in the bottom line, and that is the orange line, yellow-orange. That is the line that's going down. That is when the turbines are getting bigger. We see that a lot of vessels will be obsolete. So the total number that is available comes down. And then we see the vessel shortage number is going up rapidly. So hopefully we're not going to be in this situation very fast, but it could be that if bigger turbines are getting on the market, that we get in this situation. Again, if we go a little bit too quick with all the data, you can always try to look back in the YouTube channel of Offshoretronic SL. You will find there the presentation again, and the whole webinar will be available for you anytime. You can watch it. So what this worst case scenario could have also a huge snowball effect in the whole industry. And we have given here already some examples what can initiate this snowball, and that is the inefficient monopile installation vessels. For example, and these are not very remote examples. So these are examples that are coming in the coming years, the coming 3 or 4 years. That if you have a monopile with a transition piece, with a separate transition piece, we see already in projects with around 60-70 meters. If we go to use a monopile, the monopile will be above 2,700. So there are quite a lot of vessels that are not able to cope with this. Then we see also an example of an TP-less monopile of 50 megawatt wind turbine in 50+ meter water, and that's also already giving some problems and headache for some contractors. There's also a situation, there's a monopile of 2,500 with an 18 megawatt that is in the planning. So again, there we see a lot of vessels that are not able to cope with this and perform the installation. So if there are no new vessels coming on the market, we go to initiate this snowball in combination with bigger turbines. And the effects will be, everybody can understand, I think, that we less fabrication requirements for the monopiles, less turbines, less jackup vessels for the turbine installation, less OEM support vessels needed, and no way we can meet the CO2 target, and a lot of investment loss, as a lot of developers are planning for projects, and if there are no vessels that can operate and install the monopiles, we see a big, large downturn. So in the bottom we have made a small animation, so to say, that the snowball will start with basically the foundations is key, and in combination with the vessels, and then it will have a snowball effect on the rest of the industry. The challenges, what can increase the vessel demand? We have a good overview what we have and what the capabilities are of the vessels that are working right now, and they are available the coming years. But what can give an extra increase in the vessel demand is the OEM, the oil and gas sector. If there are more projects coming online there, in combination also with the decommissioning, maybe the day rates are better and the conditions are better for the contractor. So maybe one of two vessels will step in that area, and then the total output will go down. There is also a risk of faster growth in the offshore wind in general, mainly in Asia, developing markets and emerging markets like India, Brazil, other areas. Colombia could be a new hotspot as well for the offshore wind. There could be also the improved monopile and transition piece combination. There could be new solutions there, allowing for split lift. But the transition pieces are getting really heavy then. That means that also the same vessels need to install a monopile, additionally have a big lift and a big work scope on the transition piece that could also giving more demand on this type of crane vessels. More wind farms from remote areas means more sailing time, is affecting the efficiency. Also the total output is going down, and vessels getting deployed for jacket installation. That's also, there are some projects, still projects in the pipeline that will use a jacket, and that has to do with the soil condition. And then also the jackup vessels that we mentioned in this report, it could be that they are finding some difficulties and operational limitations due to soil conditions and maximum lifting capacity. So that could also give a negative effect. Slowdown, there's also always a risk on the other side of the spectrum as well, that we can have a slowdown in the vessel demand. And that's a little bit of technology limitations for the split monopile TP connection. We hear some, we have been discussions with a lot of people within the industry, and they see maybe this could be a small bottleneck at one point, but I think also so many companies coming with clever solutions on the market maybe will not be the case, but there is always a risk there. So we highlight it. Supply chain cannot cope with the increased demand. It could be the full supply chain, including the monopile fabrication, but also other components, skill shortages within the industry, on the vessels, and also onshore in the supply chain, and then the shortage of wind turbines and tower fabrication. There are some predictions that the tower fabrication could be a bottleneck in 2028-29. But there's still a few years to go, so maybe we'll find their solutions as well. A shortage of monopile transport vessels, the transport vessels that will bring the monopiles from China to Europe and then from Europe to the US market. And then also floating wind at one point, if that makes big developments, that could be also maybe competitive to the triple XL monopiles, because there's a lot of weight and a lot of steel in there. So solutions, long-term, short-term solutions. If we start with the short-term, on the top of the list is of course more vessels, and we should start to think about this now. And there's a lot of operators already looking at this for a couple of years, but they are not pulling the trigger. But we definitely need more vessels in the range of 3,000 to 4,000 metric ton. And also, there are some talks even on government, and in Europe, we have the Europe Committee to cap the evolution of the wind turbines about around 1820. But as we see the market right now, and we see maybe the market will adjust by itself. If there are no more vessels coming, bigger vessels on the market, you're not able to install the monopile, so we have to adapt there. And the operators and wind farm developers have to make a decision then to stick on the smaller turbines. There is also a lot of research going in to reduce the weight of the monopiles. that could have also a positive effect. And also there are some companies looking at to upgrade their jackup vessels for monopile installation, but it will come with some cost. And also, is the time enough to step in this market, and then your vessel get obsolete because the turbines and the monopiles are going quite big in size. Long term, again, the cap that could be a good solution. Hopefully, at one point we go in that direction. And then also create a better investment horizon for the vessel owners and contractors, so they can pull the ticket. And this maybe comes also with help from governments, maybe the European Committee. I see we're frozen. Let's see what's happening. Yeah?
I can hear you clearly, Jeroen.
Yeah, I have a frozen screen. I cannot move the slide. Let me see what is happening with my computer right now. As always, let me check. No. Jacob, you still there?
Yes, I am still there. I can hear you clearly, Jeroen.
Yeah, okay. I cannot, you can hear me clearly, but I cannot.
And now you switched over to slide number 19, so the audience can see that.
Okay, thank you. Then I will open on another screen my presentation. So it is, it's always happening. We are working with computers, and always something is happening. Let me open up. There, okay, I can see myself again. But you can still hear me, Jacob?
Yes, I can.
Yeah. Okay.
Yes, I can.
Okay. Let's go back to the long term. I can see. I can only not see myself, but that's okay. So we see the long term is again the wind turbines. We need to try to come with a solution there, because it will affect the whole industry at the end of the day. And also better investment horizon for the vessel owners, that they see a longer horizon to invest in these vessels. Also, the World Bank is getting involved right now to support projects in emerging markets. That could be worldwide, even in Africa and other parts of the world, that the World Bank is maybe investing in new projects, and that if we see more of these projects coming, there will be investors stepping in, and also vessel owners and shipping owners to come with more vessels. If we draw some conclusions from the data that we went over quickly over the last 15 minutes, we see there, I think also we go in a little bit extension of the webinar. I hope everybody can stay online. We have a video that can show you what we believe is an optimum vessel. Right now there are two vessels that we see as optimum vessels, and that's the vessel from Jan de Nul, the Les Alice, and the Baltica Star. That are vessels that can operate in this 3,000, 4,000 ton, 120 meter long monopiles. They are transport vessels as well. They have a large and flexible transportation capacity. They're floating vessels, and also I think the optimum vessel should have a very low environmental impact and fuel consumptions. Then also fast mobilization and transit speed is a plus. Plus, if you can pass the Suez Channel or enter the Baltic Sea, could be a plus. Let me start a video of hopefully.
And more than 80% of all offshore wind turbine installations will be using monopiles as a foundation.
Sorry, can you see this video? No, eh? No. Okay, well, I will reload it. Something goes wrong with the, but hopefully we can work around it. Let's see if we can open it this way.
Offshore wind energy is expanding rapidly worldwide, and more than 80% of all offshore wind turbine installations will be using monopiles as a foundation. As a result, there is a growing need for monopile installation vessels. Interestingly, this segment of the offshore wind market is the most underordered within the industry. With this vessel shortage will come also new opportunities. Let's have a closer look at a new vessel Offshoretronic, a marine engineering company from Barcelona, Spain, have developed with assistance of their technology partners. The new monopile installation vessel is a fast-track solution for the fast-growing offshore wind industry. Let's zoom in to all the enhanced capabilities of the new vessel, called the Baltica Star. The vessel will be equipped with next-generation EGCS filtration system with innovative technology that filters sulfur, CO2, and 99% of ultrafine particulate matter. With the CO2 capture capabilities, the Baltica Star will have the cleanest environmental footprint within the whole fleet of heavy-lift crane vessels. The next enhanced feature is the fully automated monopile transport system, allowing for safe transportation without the use of the main crane. This will allow for large time saving and dual operation when main crane unit is assigned with other tasks. The transporters are also fully integrated with the automation of the ballast and anti-heel to keep the vessel trimmed at all conditions. The vessel comes also with an enhanced capability for upending and lifting monopiles up to 4,000 metric tons. The gripper/tensioner is designed to handle a range of monopile sizes. To allow manipulating of the monopile quickly and safely from horizontal to vertical, Offshoretronic has developed a unique appending table that is fully incorporated in the vessel's hull. This design will save for more than 50% of components that are used on older designs of upending hinges and tools. To prevent plastic deformation and bending of the monopile during the upending process, we support the monopile that can reach up to 120 meter long and with a diameter of maximum 14 meters at 3 point. At the center of gravity area of the monopile, a special design saddle will be in line with the pivot point of the upending table and will handle most of the load. The monopile gets additional support from the gripper/tensioners who will safeguard that the monopile will stay in the support saddle when entering the splash zone during the upending process. The bottom end of the monopile will be supported in a shoe that will be supported by the 3 outrigging legs. At the top end of the monopile, the main crane will take care of a very smooth lift with very low loads, as we have created a large counterbalance weight at the bottom end. When entering the splash zone, we will experience some hydrodynamic buoyancy forces by wave slopes or sea currents pushing on the monopile. With our unique setup, we will allow for a fully controlled and safely upending process and extending the workability window of the vessel unit. Let's now swing over to the motion-compensated pile gripper. During the swing over of the monopile, it will stay well within the 5,000 metric tons lifting range of the main crane unit. This will allow us to lift and transfer monopiles up to 4,000 metric tons in a very safe way. Offshoretronic engineers have developed a new and more efficient solution to guide monopiles during the installation phase. The optimized technology applied to this pile gripper will fulfill strict regulations and clients' requirements to keep the pile within an offset angle that shall not go over 0.25 degree. To ensure this, a robust control method is required to deal with massive forces. Offshoretronic have come up with new approach and design. The unique gripper have additional to others designs a active roll motions compensation. The most significant improvement that have been applied is that the whole weight of the entire gripper is supported by 5 large tire sets with a total of 20 wheels with a total capacity of around 1,500 metric ton. The wheel sets are fully integrated in the gripper section with hydraulic cylinders that can also compensate for roll motions of the vessel. The wheel sets have also drive motors to assist with the top hydraulic cylinders to compensate the vessel motion in Y direction. With this unique setup, we created extreme low frictions in the horizontal plane and will give a large energy savings to put the gripper in motion. With the new innovative approach and solutions, we are able to extend the capacities and maximize the workabilities with a monopile gripper that will require low construction and maintenance cost. The gripper have no any outrigger tilting function, and this will save for a lot of hydraulic and mechanical components. With the horizontal skidding platform, we also created a very easy access to perform maintenance on the gripper and the noise mitigation system that is an accessory but have for good reasons not showed on this video animation. To finish this presentation, we will summarize all the enhanced features the Baltica Star is carrying to be a very successful crane vessel to help and accelerate the offshore wind. The vessel have the capacity to transport and install monopiles up to 4,000 metric tons, and with total length of 120 meter and a maximum outer diameter of 14 meters. The vessel have dual and parallel operational capabilities with a fully automated monopile transporter system that will allow the main crane to carry on with other tasks. Last but not least, the vessel have the ability to capture CO2 emissions and will be the cleanest offshore installation vessel on the market. If you would like to learn more about this vessel, just drop us an email, info@offshoretronic.com.
Hello, can you hear me? Okay, thank you. Yeah, I see we were running a little bit out of time, so I try to finalize then the presentation. I don't see myself anymore on the screen, but you can hear me, so it's most important. Final conclusions from if we analyze the installation market is that we, with an installation vessel with a 5,000 ton crane, should be future-proof, yes or no? And our conclusion is yes. With the right selection of the mission equipment, as showed in the video animation, you're able to install monopiles of 4,000 ton. And the quadruple monopiles from 4,000 ton is a very niche market, so it doesn't make any sense to go to reach this 5% in the market if 95% will be below the 4,000 ton monopile. Sorry, when only what we say here is the vessel future-proof? Yes. Also, when only one new vessel entering the market segment, the end clients and the wind turbine makers will be forced to adapt the market. It's quite clear that if certain vessels are available, the end clients, they have to make a selection on the turbine, and also the turbine manufacturers. Maybe at one point they see a little bit horizon that there is no demand of bigger turbines, and that goes to stabilize more the market. Monopile and transition piece solution and technologies could be a solution as well. If we split the monopile with a bigger transition piece, we have two lifts and we can split the weight. That could be also a solution, and then this vessel, the 4,000 ton or the 5,000 ton crane vessel, could be sufficient for future demand. There's also some strong signals, and this is what we pick up when we are talking with industry specialists, that the monopile design officers are addressing already that it is physical that we reach the entering the zone of physical limitations of going bigger than the 4,000 ton. We're not going in details there, but it looks like that we come at one point and at limitation on the size and the weight of these monopiles. And that's the same also on the hammer. And that's the last point, that also on the pile hammers and the noise mitigation systems, we see also limitations there. I had a few more slides, but I want to skip them for now. I just have my last slide. I hope you can still hear me. And that is, we try to keep the spirit high. Even some of the slides looks really dramatic in some scenarios, in worst case scenario. But if we keep the spirit high and we are focusing only on what's possible and not on what is impossible, we can keep a healthy market. I leave also my phone number and my email address here in the presentation. Again, the presentation you can see again on YouTube. You're on the YouTube channel of Offshoretronic. And yeah, that's a little bit from my side. Jacob, if you have anything to add.
I just also wanted to say thank you for your attention, for participating in this great event. It was my very first time that we went live, and I'm looking very much forward to have another presentation with you, Iron. Many thanks also to you for your hospitality here during this event.
Yeah. Also, I like the same, Jacob. Also, thanks for your excellent contribution, and also I would like to thanks PES for the facilitating their LinkedIn website and all the technical support. There is on the we have received a few questions, but we are running a little bit out of time. I would like to suggest that if people have any questions, please drop us an email, and then we can answer that. And just hopefully the next time we are a little bit better prepared, and we have a little bit more time to answer all the questions. I see also not all the questions are coming up here in a notice board, because there are some problems with mainly with LinkedIn. But I hope you enjoyed this webinar. And again, you can always watch back on the YouTube channel, and please drop an email if you have any comments and feedback on this webinar. And hopefully the coming years, the market can adapt in the right way, that everybody can benefit, and we can have a healthy market in the offshore wind. Thank you. And hopefully maybe we can set up another webinar in the future. I will let you know. Thank you for everybody. Bye-bye.